So, if your kitchen inexplicably smells like, the ghost of a dinner party from like 3 nights ago, the culprit is probably not in your garbage can.
Right, it's definitely not.
And it's not in your sink drain either. It is literally hiding in plain sight.
Oh, absolutely, because every single time you cook, these microscopic aerosolized oils just kind of float through the air,
Yeah.
and they settle onto the actual architecture of your gas stoves. It creates this totally invisible, sticky film.
Which is so gross to think about.
It is, and over days and weeks, that film acts like a glue. It traps airborne dust, airborne bacteria, and then, well, it begins this slow, invisible process of basically biological decay.
Yuck. So that's the smell. And that brings us to the core mission of today's deep dive. We are looking at a masterclass video by the YouTube channel Clean That Up.
Yeah, their guide on cleaning a gas cooktop is incredible.
It really is. But we're moving way beyond just surface level wiping here for you guys. We're going to dismantle the appliance, examine the actual chemistry of degreasers, and, look at how to prevent long-term damage.
Right, like irreversible rust and those horrible enamel scratches.
Exactly, because it's a pervasive issue.
Oh, for sure. The structure of a gas cooktop is just fundamentally different from, say, a flat glass electric range.
I mean, you're dealing with a really complex delivery system for open flame.
Right, so when you just wipe a wet rag around the burners, you're essentially just skimming the surface.
Just pushing the dirt around.
Exactly. You're actually pushing organic matter deeper into those mechanical crevices.
So the underlying philosophy here is like a structural reset.
Yes, a total reset. To stop those phantom odors, you have to approach the cooktop not as just one big surface, but as a collection of individual interlocking parts.
Okay, let's unpack this for a second, because my immediate reaction is just a bit of hesitation.
I get that.
I mean, are we treating a kitchen chore like we're, I don't know, rebuilding a car engine?
It sounds intense, I know.
Pulling the entire assembly apart just feels like a massive escalation for a normal Tuesday night cleanup. It introduces so many moving parts.
Well, the car engine analogy is actually quite accurate, both in terms of the complexity and the necessity.
Really?
Yeah. The reason a full teardown is mandatory goes back to those aerosolized oils we talked about. When the heat from the flame hits those settled oils, it fundamentally changes their chemical structure.
Oh, so it cooks the oil that's already sitting there.
Exactly. They cross-link and form this tough, almost plastic-like polymer.
Wow.
And this polymerized grease, it absolutely loves to anchor itself inside the invisible seams where the burner heads meet the stovetop base.
So you physically just can't reach those anchor points if it's all put together.
Exactly. Leaving them behind is exactly what causes those lingering, stinky odors. You have to take out the heavy iron grates, pop off the burner caps, and lift out the burner heads.
Okay, so the phantom smells are literally baked into the joints of the stove. But disassembling a highly engineered appliance introduces the real risk of putting it back together totally wrong.
Which can be dangerous.
Yeah.
But the source material offers a brilliantly simple preventative step for this.
Right, the photo trick.
Yeah. Before you move a single piece, you take out your phone and snap a clear picture of the entire cooktop.
It's so simple but so smart, because gas cooktops are deceptively complicated.
They really are. The burner caps are intricately calibrated to individual burners.
Like, the cap for the low-heat simmer burner is structurally different from the rapid boil one, right?
Exactly. And if you swap them by mistake during reassembly, the gas flow gets completely disrupted. You could get uneven heating or, honestly, a localized fire hazard.
Wow, okay, so that photographic blueprint is your fail-safe.
Exactly. It eliminates the guesswork entirely.
All right, so now we have the appliance dismantled. We're left with a counter full of greasy, heavy components and this exposed stovetop base.
It looks like a disaster zone at this point.
It does, and you obviously can't clean all of it at the exact same time. So we need a strategy. We have to let chemistry do the work on the parts while we tackle the base.
Right. This is the triage phase. We need to submerge those dismantled parts in a cleaning solution.
But there's an immediate problem there. Most kitchen sinks are just not big enough for those massive cast iron grates.
Ooh, attempting to maneuver them in a cramped sink is a nightmare. You get water everywhere and you scratch up your stainless steel basin.
Yeah, I've definitely done that. So the workaround here is incredibly practical. You just bypass the sink entirely and use a standard heavy-duty plastic storage tote filled with warm water.
Yes. It's such a game changer.
It's like creating a specialized jacuzzi just for your stove
A
part.
greasy stove jacuzzi, yeah. And from there, The creator introduces this diagnostic tool they call the mesometer.
I love the mesometer. It's a scale of 1 to 10, right?
Yeah. So for levels 1 through 5, which is your standard daily cooking residue, you just add regular Dawn dish soap to the warm water.
But if things escalate to a 5 through 8 on the mesometer, say after a big holiday dinner with a lot of frying.
Then the source recommends upgrading to Dawn's professional heavy-duty degreaser.
Okay, so I have a question about this. If the professional degreaser is so strong, why wouldn't you just use that every single time to save time?
That's a great question. Basically, deploying industrial-strength chemicals on standard, everyday grease is just unnecessary and it's pretty harsh on the environment.
Makes sense.
To understand why, we have to look at the chemistry of soaking. Standard dish soap has these molecules called surfactants,
Right.
and they have two distinct ends, a hydrophilic head that loves water and a hydrophobic tail that desperately wants to avoid water and bonds with fats instead.
Oh, so it's essentially like a team of bouncers at a crowded club.
So
The hydrophobic tails grab onto the unruly patron, which is the grease, and they surround it, while the hydrophilic heads link arms with the water.
that is a perfect visualization. They form this spherical structure called a micelle around the grease, totally encapsulating it.
And once it's trapped in that little sphere, it's just suspended in the water.
Right. It physically cannot reattach to the metal grate. It just washes away.
But standard soap only works for the soft stuff.
Exactly. It's optimized for soft, biological fats.
Oh.
But when fats have been repeatedly exposed to high heat and turn into hard polymers, standard surfactants just bounce right off that hardened shell.
Ah, so that's when you bring out the heavy-duty degreaser.
Yes, you need the harsher solvents to chemically break down the polymer shell first, so the surfactants can finally get in there and do their job.
Okay, so while our parts are soaping in their soapy jacuzzi, we have to attack the base of the stove itself.
Which introduces a whole new set of risks.
Yeah, because the very first step the video recommends for the base completely violates standard cleaning logic.
It really does. People always want to grab a spray bottle first.
Right, but you don't. You reach for a totally dry vacuum cleaner.
Proceeding immediately to a liquid cleaner is literally the most common mistake people make, and it causes permanent aesthetic damage.
It's like sweeping a hardwood floor before you mop, which makes sense in that context, but applying it to a stove feels totally counterintuitive.
I know, but you absolutely must execute a dry extraction first. You use a soft bristle brush attachment to vacuum up the large debris, the salt crystals, the crumbs.
Why is that dry vacuuming step so critical, though?
What's fascinating here is it comes down to the physics of friction and the Mohs hardness scale.
Okay, getting scientific.
Well, think about spilled salt crystals, burnt peppercorns, or even hard little grains of rice. They are actually quite hard.
Harder than the stove's finish.
Yes. The enamel or stainless steel is actually softer than those materials.
Wow.
So if you spray a liquid cleaner directly onto dry debris, you create this abrasive liquid slurry.
And then you start scrubbing.
Yep. You take a sponge, apply downward pressure, and you are literally dragging microscopic jagged rocks across your appliance.
Oh man, you're inadvertently sanding the finish off your own stove.
Exactly. Skipping the vacuum step guarantees permanent micro scratches.
Okay, so once the abrasive crumbs are safely vacuumed up, then we transition to the wet scrubbing.
Right. The source uses Dawn Power Wash, sprayed evenly across the base.
And they pair it with a very specific temperature-sensitive tool. A non-scratch scrub sponge, like a Scrub Daddy or Scrub Mommy, warmed up in water first.
The temperature manipulation there is a highly calculated technique.
How so?
The polymer foam in those specific sponges actually changes its structural rigidity based on heat. Cold water makes the foam rigid and highly abrasive.
Like for tough scouring?
Right. But warm water relaxes the polymer chains. It makes the sponge soft and pliable.
So by using warm water, it's tough enough to push through the grease, but gentle enough to not scratch the delicate enamel.
Exactly. It's brilliant.
And then you combine that warm sponge with the standard toothbrush for the really intricate detail work, like around the starters.
Yes, but we have to mention a massive operational hazard here.
The gas holes.
Yes. When you have the burner parts removed, the raw gas delivery ports are completely exposed. You absolutely cannot spray cleaner down into those openings.
Or even let liquid pool near them, right?
Right. It's a matter of functional preservation. The gas ports are precisely calibrated. If soap or food sludge falls into those microscopic openings, it will dry and calcify.
Creating a literal physical blockage inside the gas line.
Exactly. The result is uneven flames, sputtering burners, or the burner just totally failing to ignite. You have to clean right up to the edge with absolute control.
But even with precise toothbrushing and warm sponges, you eventually hit a wall.
Oh yeah, the level 10 messes.
Yeah, like when pasta water boils over and hits the hot enamel next to an open flame, and it literally carbonizes.
It turns into a concrete-like substance.
Yeah.
Standard mechanical scrubbing is useless against that.
Which brings us to extreme measures, the razor blade scraper.
Yes?
And here's where it gets really interesting, because the idea of taking a literal, sharpened steel razor blade to a delicate kitchen finish sounds like deliberate vandalism.
It is incredibly intimidating. But the source has two unbreakable rules to mitigate the risk.
Rule number 1, always lubricate the surface. Never, ever scrape dry enamel.
Right. The liquid cleaner creates a microscopic buffer layer between the steel edge and the finish.
So you want the razor to basically hydroplane beneath the carbonized food.
Exactly, lifting it away. Without that liquid buffer, the friction spikes, and the steel blade will immediately dig into the enamel and cause a massive gouge.
And rule number 2 is about the blade itself. You have to use a brand new, factory-fresh razor every single time.
Yes, and the primary reason is oxidation.
Rust, basically.
Right. Steel is highly reactive. If a razor has been sitting in a drawer for 6 months, it's likely got microscopic rust along the edge, even if it looks perfectly clean to the naked eye.
And rust isn't smooth.
No, rust is jagged. A slightly oxidized blade acts like a microscopic serrated knife.
Yikes, so it'll just leave a trail of deep scratches across your stove.
Exactly. A fresh blade ensures a perfectly uniform, smooth edge that distributes the pressure evenly.
Okay, so that takes care of the flat base. But what about those heavy cast iron grates soaking in our tote bin?
Yeah, the jacuzzi.
Right. If those are covered in fully carbonized, baked-on grease, Dawn dish soap is not going to cut it.
No, it won't.
And you can't easily run a flat razor blade over the complex, curved geometry of a heavy grate. So we have to escalate the chemistry.
This is where the ammonia off-gassing method comes in.
Which is a huge shift. We're moving from mechanical scraping to aggressive alkaline chemistry.
The protocol is very specific here. You take the heavy-duty cast iron grates and put them inside a heavy-duty garbage bag.
And then you add just 1/3 of a cup of liquid ammonia to the bag.
Right. You seal it completely airtight and place the whole bag inside a rigid plastic bin and leave it for several hours or overnight.
Okay, the volume of liquid is what totally caught my attention here. 1/3 of a cup is like a tiny puddle.
It really is.
It's mathematically impossible to submerge a massive cast iron grate in 1/3 of a cup. So how does an isolated puddle of ammonia actually clean anything?
It's fascinating. The liquid ammonia is actually not the cleaning agent.
Wait, really?
Yeah, the mechanism relies entirely on volatility and off-gassing. Liquid ammonia evaporates extremely rapidly at room temperature.
Oh, so it turns into a gas.
Yes, an alkaline gas. By sealing the bag, you create a contained atmospheric pressure chamber. The ammonia gas expands and fills the entire bag.
So the gas is physically wrapping around the complex curves of the cast iron, reaching all those tiny spaces a sponge could never get to?
Exactly. And because it's a gas, it has zero surface tension.
Right.
So it can penetrate the microscopic porous structure of the cast iron. Polymerized grease is slightly acidic, so this highly alkaline ammonia gas initiates a chemical reaction.
It basically attacks the bonds holding the grease together.
Right, it attacks the ester bonds. Over a few hours, the gas literally dissolves the molecular glue bonding that carbonized food of the iron.
So the grease just detaches and slows right off.
It just melts away. The gas does all the heavy lifting on a molecular level.
That is incredible. And the final instruction, putting the sealed bag inside a rigid plastic bin, that's a vital safety step, isn't it?
Absolutely, it's hazard management. A heavy grate has sharp corners. If it punctures the plastic bag in the middle of the night, you really don't want highly potent ammonia seeping into your hardwood floors.
Definitely not. The bin is your containment failsafe.
Right. Now, once all this chemical intervention and scraping is done, there's a huge psychological tendency to just view the job as finished.
Because the dirt is gone. It looks clean.
But removing the grime is only phase one. How you manage the chemical residue and treat the bare metal afterward dictates the actual lifespan of your appliance.
Which brings us to the rinsing phase. The source emphasizes this heavily. You can't just wipe the visible suds away and call it a day.
No, you must extract every single trace of the cleaning agent from the surface.
Because soap, by its very nature, is designed to attract particles, right?
Exactly. If you leave a diluted film of surfactants on the stovetop, it dries into this slightly tacky hydroscopic layer.
So what does this all mean for the listener? It means a lazy rinse actually accelerates the degradation of your kitchen.
Yes, that invisible layer of tacky soap pulls moisture and airborne dust right out of the room,
It becomes a literal magnet for new grime.
which means your stove will get dirtier much faster than if you hadn't even cleaned it at all.
That is wild. Plus, it leaves terrible visual streaking, especially on a black cooktop.
Yeah, it looks awful. You have to strip the agents away completely with fresh water and then buff the surface to a flawless finish using a dry, clean microfiber towel.
And while the base needs careful buffing, the cast iron components demand even more care.
Right. If we connect this to the bigger picture of cast iron care, after you pull the grates out of the soak and scrub off the loosened grease, the critical phase is the immediate aftermath of washing.
Thorough, absolute drying.
It is non-negotiable. Cast iron is essentially a rigid metallic sponge made of iron and carbon,
It's super porous.
highly porous, and exceptionally reactive to water and oxygen. If you leave even a microscopic layer of moisture trapped in those pores after rinsing, the iron will immediately begin to oxidize.
You'll trigger rapid rust formation.
Exactly. The structural integrity of the metal will degrade, rendering all that deep cleaning completely pointless.
To counter that, the source offers this amazing preventative trick. Once the cast iron is meticulously dried, you take a paper towel and apply a remarkably thin layer of cooking oil.
Like avocado or olive oil.
Yeah, across all the iron components. You're basically seasoning the stovetop grates exactly like you would season a cast iron skillet.
It's so smart. You're utilizing the unsaturated fats in the cooking oil to your advantage.
To create a barrier.
Exactly. By applying that thin layer, you're intentionally creating a purposeful polymer shell. The oil acts as a hydrophobic barrier.
A physical sealant that blocks ambient moisture in the air from ever reaching the vulnerable iron underneath.
It completely neutralizes the threat of oxidation. And as a bonus, it restores that rich, dark, factory-fresh look to the metal.
It makes it look amazing.
Yeah.
So with the base bucked and the cast iron sealed, you pull out that photographic blueprint you took at the very beginning.
Time to reassemble.
Yep. You use the photo to precisely seat every burner head and cap back into its calibrated position.
The puzzle goes back together perfectly with zero risk of misaligned gas flows.
But this comprehensive teardown and chemical reset requires a lot of effort.
It's a huge project.
Which is why the ultimate objective here is establishing a maintenance routine so you don't have to deploy razor blades and ammonia bags every single week.
Right. The recommended maintenance schedule is deeply pragmatic. First, you just wipe down the stovetop with a damp microfiber towel immediately after each cooking session.
Just to remove those aerosolized oils before they have a chance to settle and polymerize.
Exactly. Second, if a spill occurs, wipe it up immediately. Don't wait.
Get it before the heat from the burner carbonizes into that level 10 cement.
Right. If you adhere to that basic discipline, this intense tear-down deep clean
Right.
really only needs to happen roughly twice a year.
The return on investment is massive. You're reclaiming hours of labor that you'd otherwise spend scrubbing hardened grease.
And you're protecting a highly expensive home appliance by preventing rust and scratches.
Most importantly, you are eliminating that decaying biological matter that causes those terrible phantom odors.
You finally get your kitchen smelling fresh again.
Exactly. But as we look at the mechanics of this entire process, the science behind the rinsing phase leaves us with this lingering, kind of unsettling realization.
Oh, about the soap residue.
Yeah. We established that leaving just a microscopic film of soap on a surface turns it into a tacky, hygroscopic magnet that actively pulls dirt and dust out of the air.
Right. It highlights a fundamental misunderstanding of how cleaning chemistry actually interacts with our physical environment when we don't apply it properly.
Which raises a really provocative question for you to consider as you navigate your home today.
I know where you're going with this.
If a rushed, lazy wipe down actually makes our stovetops significantly dirtier over time, how many other surfaces in our homes are currently coated in an invisible trap?
It's a scary thought.
Are our kitchen counters, our bathroom tiles, and our hardwood floors actually dirtier today precisely because we tried to clean them yesterday?
Wow.
Perhaps the reason a room never feels truly clean isn't a lack of effort, but a surplus of leftover chemistry. Just something to ponder the next time you reach for a spray bottle. Thanks for joining us, and we will catch you on the next deep dive.